Welcome to part 2 of my CNC build. If you haven't seen the frame build in part 1, you can click in the link in the corner or in the description below. With the machine frame ready, it was time to install the electric components. The frame provided two separate spaces under the machine bed that I had connected with cable channels. The idea was to place the Arduino and the motor drivers in the front, separated from the power supply, which was going to be placed in the back section. Each component was going to get fresh air supplied by small blower style fans. The holes in the bottom were for the fans to pull in air, while the holes in the sides were to exhaust the hot air. I installed all 4 motor drivers on an aluminum L bracket with the cable connectors facing up and the heatsinks facing down. Then I mounted the little blower style fans. They only have a diameter of 50 mm but can provide a good amount of airflow and also run on 12 volts. I elevated them with a section of plastic tubing to a height where they could blow fresh air right across the heatsinks of the drivers. One fan was installed to provide airflow for the Arduino, and the Arduino itself was mounted on 6 mm motherboard standoffs. Before we start with the wiring, let's have a look at the remaining components. The spindles are driven by 4 NEMA 23 stepper motors with a stepping angle of 1.8 degrees and a maximum current of 2.8 amps. The drivers are rated for a maximum current of 4 amps and can be set to provide the needed amount of current by adjusting the little switches to the position as indicated on the table. For the Arduino, I purchased a CNC shield. Even though this wasn't absolutely necessary, I found it helped a lot with the wiring because everything is nicely labeled. Finally, we have a 12 volt 15 amps power supply, which with its 180 watts is more than capable of providing enough power for all the components. For each axis I installed 2 limit switches as hard limits to protect from over traveling and also to be used as homing switches. They were connected in the normally open configuration, which would send a signal to the Arduino if the circuit was closed and immediately stop the machine. As an optional feature, I decided to add an LED light strip to the X-axis to provide lighting during machining and also just for a nice look. Before we go into the wiring and cable management, let's have a look at how all the parts are connected with each other. In the diagram you can see all the components we just discussed, as well as 4 switches in the front of the frame. A main power switch and 1 each for the router, the fans and the LEDs. In the back of the frame are the 230 volt socket and the USB power connector. I routed the USB cable from the back of the frame to the USB port of the Arduino. The 5 volts from the USB are the only power source the Arduino needs to run. I hooked up the power supply with the 230 volts power plug in the back of the frame via the main on-off switch in the front of the frame. The router was the only component running on 230 volts as well, so I connected it to the 230 volt power source also via its dedicated on-off switch. Next up were the 12 volt connections. The power supply provided 2 12 volt sockets and I ran the positive wire to the VCC port of all 4 motor drivers, while ground was connected to the ground, pulse minus and direction minus ports like so. From the second 12 volt port of the power supply, I ran the power to all 6 fans via the fan on-off switch and then also provided power to the LED strip via its dedicated LED on-off switch. Next I extended the 4 motor wires of all 4 stepper motors and connected them to the drivers A and B plus and minus ports like so. I made sure to use thick enough wire with a 0.75 mm cross section, which is equal to an 18 gauge wire. Then I had to connect the direction and pulse plus ports of the motor drivers with the matching axis step and direction pins on the CNC shield as shown here. The last components to connect were the limit switches, which had to be connected to the CNC shield's respective pins. In order to avoid electromagnetic interferences, I used shielded cables for these connections. A further precaution that I took was to add capacitors, which should further help to avoid false triggers. Now let's move away from the schematics and have a look at the actual cable management. I started by inserting the USB cable and the 230-volt power plug into the back, as well as putting all the on-off switches into the front sockets. I routed long enough cable sections through the drag chains to the motors, the limit switches and the LED. Then I fed them through holes that I had drilled into the machine frame to the motor drivers, the Arduino and the power supply. Once all the cable routing was done, the rest was connecting the cables according to the schematics. Now let's have a look at the software I'm using to run the machine. The CAD software I'm using is Fusion 360, which is available for free for private use. It incorporates a fantastic CAM module to generate the G-code to run the machine. It's quite simple to learn and yet very powerful, and there are many good tutorials available to get started. The machine is running with Gerbil, which I flashed onto the Arduino with IDE, Arduino's integrated developer interface. To send the G-code to the machine, I'm using Universal G-code Sender, which can be downloaded on the GitHub homepage. This is also the place where parameters such as hard and soft limits can be enabled, and feed rates and acceleration can be adjusted. All this software is available for free, and there are plenty of good tutorials available to get started. My first machining job was to make some hold-down clamps for easier mounting on the machining table. At startup, the CNC is going through a homing routine to determine its absolute zero position. It drives in the minus direction of each axis until it hits the limit switch, backs off, and then approaches again more slowly to move away again by a set distance. From this position, the machine can now be directed to the desired starting point of any job, and its work position can be zeroed and the cutting job started. I monitored the power draw of the machine and the temperature in the electronics compartment during the first run. They both stayed at very acceptable levels. The cooling system seems to provide enough airflow that the electronics will stay cool also during extended use of the machine, and the power supply can operate at an efficient level of around 50% without overheating. I've only just started to play with my CNC and I must say that it's a lot of fun and I'm very much looking forward to experimenting much more. The entire building process has also been a huge learning curve, and so far I'm actually very happy with how the machine turned out and how it performs. You're definitely going to see the machine in action in future videos, where I'll also be going into greater details about the working process. I really hope you enjoyed this video. Thank you so much for watching and see you for the next project. Bye for now.